Hello, everyone. I hope welcome and good afternoon to my lecture. First of all, I would like to share my PowerPoint slide, and I hope everyone can listen to me loud and clearly. Just in case that the network become unstable or any instability, so please excuse me. Maybe I will rejoin the chat room very soon. Okay, so I wish I wish the PowerPoint can be shown on your screen clearly. Is that correct?
Yeah, that's very clearly.
Okay, cool. Okay, so let's start our lecture. Actually, I would like to say this as a sharing instead of a lecture because I would like to share my knowledge and some of my experience about the aerial photography by UAV. And welcome again to this lecture 4. The aerial photography by UAV is a very big part in the GIS application, so it can be used in a wide range of area. Just before that, I would like to introduce myself first. My name is Lawrence, so I'm Lawrence Chou Lok-Man, and you can call me just Lawrence. I'm a technical specialist at the UAV team in the Fengyao University. So in Taiwan, and we need to have a license in order to operate the UAV. Therefore, I'm a UAV course lecturer in Fengyao University. I've been doing my work for around a couple of years. I would say around 4 years. And then I'm also an UAV operator. I operate the motor rotary UAV and also fixed wing and single rotary UAV. So for some of you, you may not have a very clear understanding about what kind of UAV is it. So I will talk about it and I will cover those topics in the following slides. So here is the course outline. There will be 5 sections. In the section 1 is the general introduction to UAV. Some of you may touch or may handle some kind of UAV in your past experience, but for some of you, you may be very new in this area. So I will talk through from a very beginning level. I'll tell you what is a UAV, and then for some structure and for some other issues. In the session 2, I will talk about the applications of the UAV aerial photography. It can be very fun, and on the other hand, it can be very professional area. So what are the applications? And I will show you in the session 2. So both session 3 and session 4 is talking about the operation procedures. Since there are large area to cover it, so I will split it into part 1 and part 2 from your understanding of the operation and to the after processing and what you have to do after your operation. I will cover those of the aspect in the session 3 and session 4. So session 5 will be our last session in this afternoon. And I will here cover some of the oral photo processing. It is some basic application in the GIS area. So, and also it is a very hot topic and very useful skills for the UAV aerial photography nowadays. Okay, so here we come for the session 1, the general introduction of UAV. I think most of you have seen some people who are playing with their remote control models, some airplanes, some helicopters. They are very fun. But what are the differences between those remote control aircraft and the unmanned aerial vehicles, which we are talking about the UAV nowadays? So the second one, and I will talk about how the common types of UAV. UAV can be something that fly in the skies, but they can be categorized into different types. So I will cover it later on. And the third part will be the onboard equipment, which we call it the payload. So those equipment can determine your success and also your outcome of your project. And the last part will be make a right choice, do the right thing. So if the operation is not a fun operation. It is for some professional use. So you need to know what is the right equipment and in order to have a good result. Okay, I hope this video can be played smoothly. This is a video that I captured in my previous operation. And you can see a plane with the wingspan around 2 meters. So it looks fun. It looks like a model airplane. But what are the difference between the remote control model with the UAV that we call nowadays? First of all, I would say is the capacity of the system. On the screen on the left-hand side is the wiring diagram, and which means all the electronic components, the most simple electronic components of a modern plane. You can see that very importantly, it has a battery. The battery provides the electricity for all the devices. Normally, it is a lithium-ion battery, just like the battery of your cell phone, and it is rechargeable. For here, I would like to show you some of the battery that UAV use. It can be as small as this one for a small UAV, and for some multi-rotary UAV, it can be as large as this one. And for the fixed-wing aircraft that you saw on the previous video, it can be as large as this one. And for the plane, it equipped to this kind of battery to power it up. Okay, the second and important element is the remote control transmitter and also the receiver. It is a pair of equipment, just like this one. It's send out the control signal from the controller, and the receiver will receive those electronic signal and then to put the action into the plane. So it can control the speed of the motor, the control surfaces, and even the on and off of all the lightings. Okay, the third part are the servos. So some of you who may not have a very clear idea what is a servo. So it is simply a device that controls the movement of the movable surfaces. So here I have another model to show you. Okay, this is a model airplane. So you can see there are lots of control surfaces to control the movement of the airplane. And the tail, we have the rudder, the elevator, and the aileron. All kind of movement require a servo to provide the movement of the UAV. Okay, and the fourth part is the motor. It is very important, of course. For any UAV, it needs to fly forward. So the motor connect with the propeller can provide the forward thrust, and subsequently it produces the lift in order for the UAV to fly in the sky. Okay, the previous slide is talking about how the wiring diagram of a remote control airplane. So how about the UAV? What are the extra elements? Very importantly is the flight computer, as you can see in the center of the diagram. So the computer, you can imagine it's just like your brain or human brain. And so it can sense the UAV status, what we call the sense, because it receives those information from the GPS sensor, from the barometer, or some internal compasses. It receives the information and also it outputs some command. It can then store the flight command. So as a controller, I can send the command to the UAV to tell it where are you going to fly to, what are you going to do, and what I want you to do. So it can store the command and execute the command. And meanwhile, it can then also coordinate the motor, the servo, and also all the control surfaces for their coordinations. The flight computer can also feed back the status to tell the controller about how the information like the battery level, where is the UAV, and what is now doing, and etc. So I will give you more information in the following video. Okay. So here are the orientation devices. What are these? So first of all is the GPS receiver. In order to execute the mission, the airplane or the UAV need to know where is the UAV. So the GPS receiver is just like your cell phone. You have the signal and telling the UAV that, okay, what position is the UAV. So it will tell it where am I and how high am I. And also some automatic guidance for the flight missions. The second one is a barometer. It is an internal device to tell about the height, the altitude of the UAV. It is a redundancy system and cost tracking system for the UAV. And the third one is a compass. It is very important because it will tell how the UAV about the heading, what direction is it heading to, and the UAV orientation. Okay, so I think this is the last one. Is the telemetry device. It is different from the remote control devices because it uses different frequency. We can call the telemetry device as the data link because it communicates between the UAV and the controller. Besides the signal transmission, it will tell something even more. For example, the speed of the UAV, how high is it, what is the heading, the battery level, the motor output, or the current and the electronic current, etc., etc., so much more. Okay, so for the second main difference between the UAV and the remote control airplane is that for those model airplane, so it always need to connect with the remote control signal, which means that the plane cannot fly too far away. Otherwise, it will disconnect with the controller and the plane will eventually crash. So the plane need to stay a line of sight, which means you can see the airplane at all the time. And therefore, the flying range is relatively short, normally less than 1 kilometer, or for some ultra long remote controlling airplanes, so it can be a little bit more. But at that situation, you can very hard to find the airplane in such a long distance. So therefore, normally the firing range for those model airplane is less than 1 kilometer. So for the unmanned aerial vehicle, the UAV, it can be controlled either by the remote control signal, the telemetry control, or fully automatic. Fully automatic means that the airplane can fly all by itself. What you need to do is to input your command into the UAV, and then it will execute your command automatically. Therefore, it can fly out of sight. Out of sight is that the airplane just take off, fly away, and you can't see it. You can just find it on the map. So of course, it depends on the battery capacity. So larger the battery, more per electricity, so it can fly for a longer time and for a longer distance. So in this case, controller is no longer a person to control the airplane, but to monitor the status of the UAV for all the time. The UAV can normally fly for a very long distance, for example, up to 100 kilometers or even more. Okay, for the third one, and is the purposes. The purposes of the model airplane and unmanned aerial vehicle is different. Model airplanes are mainly recreational. It can be fly for fun. It's really fun to fly. Everyone can fly it, from the kids to elderlies, as long as you have such habit, you have such hobby, so you can fly the model airplane. And you can fly as a leisure hobby, skills competition, or some realistic models. And for the UAV, it is always mission oriented, which means that different mission has different type of UAV, and all the mission and is specifically designed for the UAV. It can be like some commercial photo taking for the land survey, law enforcement investigation, or so on. And the most importantly, it required a very professional skills. Okay, so here is another video that I captured in my previous operation. So you can see that both remote control airplane and the UAV, they can all take off with the manual control. And we can receive a lot of flight information through the telemetry and the video link. And you can see more in this video. Okay, so in this screen, we have a lot of information from the airplane. You can see here is the battery voltage and also the current feedback from the UAV. Also the height, it was currently around 210 meters high. And what are the headings? How far is it from the station? So how we can know a lot of information from the airplane. And this is the interface for the operating UAV. So it seems very complicated, but simply it can be divided into two halves. For the left-hand side, it can tell you something similar about the speed of the UAV. How high was it? It was around 900 meters high, and the altitude of the UAV. So on the map, on the right-hand side, you can see a lot of dots. So what are these? These are the commands that are given by the controller to tell the UAV what command or what action it needs to take when the UAV fly across this GPS position. So in this case, this is a photo taking mission. So he took a lot of picture all the way when the airplane can fly in this route. So for every point, so when the aircraft arrive this point, it will take one picture. And you can see all the way we fly in a zigzag way, and it will eventually take 346 photographs in that mission. So it will tell you, the UAV will tell you the exact action, what the UAV is now doing. Okay, so here are the common types of UAV. So even though UAV is a common term for those aircraft that are controlled automatically, however, there are lots of different types. The most common one is the one that on the left upper corner is a fixed wing UAV, just like an airplane. It is indeed an airplane. It needs a one-way to accelerate on the ground and then take off. It can fly for a very long distance and can stay in the air for a long period of time. It can powered either by battery or powered by gasoline. So for the second one, on the, I should talk about this one first. So the second one on the left lower corner is the single rotary UAV. It is something like a helicopter. So it has a main rotor on top of it, and then it rotate, provide the lift, and then the aircraft just take off. It doesn't need any one way to take off from the ground. So the third one is the vertical takeoff and landing UAV. We call it VTOL, the VTOL. it is a kind of UAV that appeared in the market in the recent year. It is something very new for us, and you can take a look of the video here. So the shape of the UAV is just like a fixed-wing aircraft. However, it equips something more from it. You can see four propellers on the fuselage, so the aircraft can take off from the ground. Okay, let me pay again. It can take off vertically from the ground, and after it reaches a certain height, so the main propeller will start turning, and it will fly just like an airplane. So the advantage of it is that it doesn't require any takeoff runway, so the takeoff area can be very small. However, it can achieve the advantage of the fixed-wing UAV, just like that it can fly for a very long time, for a long endurance, and also a long flying range. Okay, the fourth one is the multi-rotary UAV. It's just like something that we can find commercially in the market, just like this one. So it has a number of propeller. For this one, it has 4 motors, 4 propellers. So it does not require any takeoff one way and landing one way. So it can take off vertically from the ground. And this is something that very common nowadays. Okay, so here I talk about how the onboard equipment. So we call it about the payload, something that extra on top, extra of the UAV. So most of the UAV has a certain payload capacity, which means that those UAV can carry some weight on top of the weight of the UAV itself. So it can be a camera, it can be a sensor, it can be a cargo, or some spray for the agricultural use. Okay, just like this UAV, you can see that it has a camera here and also a gimbal. So for this part, we consider it as the payload. So normally, a larger UAV, so it has a higher payload capacity, which means that a bigger UAV, it can carry more weight. So usually for a mission, a usable payload should be starting from about 500 grams. So it can carry a small, tiny camera in order to do some, let's say, survey or some GIS application. And of course, heavier the payload, so it required more power and more energy for the motors. So the flying time is shorter. That's why it is always very important to take the equilibrium. You know your mission, and should you take a very heavy payload and then the flight time is very short, or you can take a very small camera and that's it. You can fly for a very long period of time. So you need to think about it very carefully. Okay, and therefore choosing the correct payload for your mission is crucially and essentially important. Okay, so here is a very simple flow chart for you to think about. First of all, how can you choose a correct equipment? Is that you understand about your mission nature. Whether you are doing a photography mission, you need to film. You need to do some commercial filming or some very nice framing. You need to do a surveillance. Different type of mission require different type of equipment. For example, for the photography, you may need some very fancy camera or some large sensor, and also for the filming as well. And for the surveillance surveillance mission, so that means you need to UAV need to stay in the air for a long period of time, which means that you may need to have a large battery instead of a large camera, so you can stay for a long time. And so for the spraying mission, so you need to have some special structure underneath the UAV, so you can spray the pesticide, or you can spray the fertilizers onto the farmland. And also the transportation, you may carry some cargo underneath the UAV. So after you know what kind of mission is that, so you can choose the correct kind of equipment for different camera specification and maybe some modification, some structure of the UAV. And later that you can select your camera. In order to carry a large payload or large camera, how big should you need your UAV? So what is your takeoff weight? And finally, eventually, the most importantly, is about your budget, of course. So price, UAV is always very pricey. So choose the right choice to do the right thing. Okay. Okay, so here we come for the session 2. I'm going to talk about how a couple of the applications of the UAV aerial photography. First of all, how it comes to my mind is that it can be for leisure, for fun photography. And the secondly is a commercial business, GIS application, and heritage preservation. So I will go through it one by the other one. Okay, first of all, I would like to share this very short video clip for you. I find it in the YouTube, and the video was made by a pair of Japanese couple. So they travel around the world with their UAV, and they capture a lot of magnificent video. Oh, sorry, I just skip it. Okay, it's really nice. It really recalled my memory of traveling. I really want to go outside now, but unfortunately, the COVID situation, we can't do it right now. But let's come back here. For the leisure photography, yes, of course, it allowed you a wide range and huge amount of creativity. So it can be very handy, and you can take out your UAV and then take off, take a picture, your video, and then got some very nice capture. It can be very convenient and fun. So here is the second one. So it's all about the commercial aerial photography. So nowadays, a lot of factory or manufacturer, they hire the professional UAV team to get some very nice advertisement. So here are some comparison. For the commercial photography, in the past, it is just like the picture on the right-hand side. It can be very risky because in the past, when the technology was not so advanced, the filming team want to carry a large camera. They can only hire the helicopter, the pilot to do so. It was very expensive, and of course, it can be very risky, particularly for those areas that with a lot of obstacles. Just like the picture here, you see a lot of power lines, and maybe the pilot was required to fly a very low altitude to get some very nice shoot. It can be very dangerous. But nowadays, as the advance of the technology in UAV, the UAV can carry a very high payload, which means that it can carry very heavy equipment. You can see a very fancy camera, a very stable gimbal, and some communication system. And it can do the same thing as what we did with the helicopter in the past. And of course, the helicopter rental could be very expensive. So nowadays, through the commercial photography by the UAV, so it can be the risk can be lower, the cost is lower, and also higher mobility and also the feasibility. Okay, so here we come home to the GIS application. the UAV can be used to do a lot of work in GIS survey. One of those is the aerial mapping. So it can take a lot of picture from a relatively low altitude and give out a very decent mapping. So I will talk about how to do those aerial mapping in the session 5. Yes, as I mentioned previously, it can comparing to those manned aircraft or those satellite images, UAV can fly in a relatively low altitude. So, which means that it is less restricted by the weather situation. For example, those cloudy days or rainy days, UAV can still fly high in a relatively unrestricted situation and then take those pictures. Because of those high mobility and almost giving you the instant result, it is very suitable for those SARS and search and rescue mission, and particularly after the some disaster happened. Okay. The UAV photography can now also apply to some historic preservation. So we mentioned previously that the UAV can carry cameras, and on the other hand, it can carry some other things, just like a laser scanner. So those operator, they can scan some historical buildings and build some 3D models with a very decent details, just like this. Okay, so the laser scanner, just as I talked about, we call it the LiDAR, the light detection and ranging and equipment. So it is something, the yellow little equipment underneath the UAV here. So its working mechanism is emitting and receiving the laser. But when the laser beam hit the surface of the structure, so it will bounce back and receive by the receiver. So how the equipment can know, okay, hey, there is a point. We call it point count. So after the scanning for a lot of point counts, so a 3D model will be built, just like the one on the lower right-hand side. So it can be very accurate, and on the other hand, the equipment is very expensive. It can cost more than 40,000 US dollar. Okay, so those digital 3D model can be a record for some historical architectures, and give the when the architecture need to be restored or some renovation in the future, it can be the reference. Okay, so here I would like to share a case study here with all of you. It's a fire, a very catastrophic fire in Paris back to 2019. So I believe some of you who may have read about or heard about this news previously. It was a fire in the cathedral in Paris. So the cathedral hall was like 850 years of history. So it is a very beautiful, elegant and cathedral. But unfortunately, a fire just brought it down, and then the upper part and some internal structure were seriously damaged. However, I would say luckily and eventually, luckily, unfortunately, that just before the fire, some expert they did some 3D scanning and modeling. And a very famous example is that a Belgian art historian, Jiann-Yeou, so he did the scanning in 2010. So the scanning, he scanned through the interior and also the exterior of the building. As I had talked about that, the LiDAR scanning, which can provide very accurate detail for all the measurements, all the parameters, all the surface structures, it can be shown very clearly. So it creates over 1 billion data point clouds, which means a lot of data for the reference. So after the fire in 2019, so his mapping had become one of the most important reference for the reconstruction of the cathedral. Okay, so we have ran through about how some applications of the UAV, and now I will here go through about how some operation procedures. So when we received some mission requirement, someone can tell you that, okay, I want to do some mission. First of all, you need to understand what you are going to do, and you need to prepare very carefully before your execution. And I will tell you more why it is so important to do this preparation. And I will talk about how some hazard when we do the operation, including the airspace, including the weather that we are facing, about the terrain, and so many more. Okay. So first of all, understand about your operation. So what is the nature about your operation? Is that an aerial mapping? Is that a 3D modeling? Or is that a surveillance mission? So different type of mission, and the skills required or your equipment is totally different. The second part is that the area of your mission. Are you going to execute a large area of mission? So you may need a larger UAV, or a fixed-wing aircraft may be a better option. So you need to think about it. What kind of camera or what kind of equipment should I carry? So it will bring the question about your payload capacity. Is there any takeoff and landing zone near your mission area? So if there's no takeoff area, so you may consider the multi-rotary UAV or the VTOL. And the type of the terrain. And are you going to fly inside the urban area, in the flatland, the mountainous area, or over the water? So it is also related to the type of equipment that you need to choose. And the last one is very important. It's about whether you can operate your UAV automatically, or will it be a manual flight? Okay. I love this title that I choose. Is a more preparation and less troubles. Throughout my experience, and it is always true, to do more preparation. And but in fact, even though I have quite a lot of experience and I did a lot of preparation, but I always feel trouble. So that's why it is always important to do more preparations. First of all, I would like to mention about the airspace. It is very important, particularly a very big issue in recent years. So when you want to fly in an area, can you really fly over there? So there are a lot of news in the newspaper or in the internet saying that some operator, they just fly their drone irresponsibly, let's say in the airport area or military zone. So it creates a lot of troubles. So how can you know whether you can fly in that area or not? So you need to check your local regulations very carefully. Okay. In Taiwan, so Taiwan is the one on the left-hand side, this one. So you can see the main island of Taiwan, and a lot of different color, the red pattern, the yellow pattern, some gray pattern, and green patterns. So in Taiwan, we have our own regulations. The authority, they create different area for the UAV operators. Some areas, particularly in the red color, is called a no-fly zone. The UAV operator can simply just cannot operate in those areas. Yellow zone is that the restricted area, so you have some kind of restrictions. So you really need to understand about your restriction before taking off your UAV, otherwise you will have trouble. And for the other maps in the middle, this is the airspace chart in Singapore. So you can see that Singapore is a very small country, of course. And for the gray area here are the areas that the UAV operator can fly. So you can see that just a very small area, and you need to follow the regulation very carefully. Otherwise, you may have some trouble. And the one on the right hand side is the Tokyo area and Osaka area. And for the one on the upper right hand corner is the in the map in Manila, some regulations in Manila. Okay, after that, I would like to talk about the weather issue. So weather is very important because it will define whether your mission is successful or not. Most of the UAV in the market is not waterproof. That means when it rains, the rainwater may get into the UAV and may create some problem. For example, the short circuit of the battery, some malfunction of the control system, or it may get into the camera and then the camera may not work properly. So of course, is your UAV waterproof? And also, in some rainy day and foggy day, those images or somehow those photo quality given in such weather situation may not be good enough. It may be blur or maybe not focused or maybe not clearly. So when we took those pictures after the mission, we always see that it is not usable. So that's why it is very important to choose not to choose a rainy day to fly. And the third one is the cloud coverage. It means that for some time, maybe even though it is not a rainy day, but the cloud may be very low above the ground. So when your UAV fly across the clouds, so you simply can't see anything. And that's why it is not only the rainy days that you cannot fly. When the sky is filled up with clouds, so it is also not a very good day to fly as well. Okay, wind is one of the very main issue when we one of our consideration when we operate the UAV. First of all, in a very windy day, can your UAV withstand such wind? Can it take off? Can it landing safely? And also, even though it can take off or it can land, the UAV, in order to withstand the wind, it will consume a large amount of battery. So it means that it can't fly as long as it decided to. And for some time, when you fly the UAV to some far distance, so can it return home safely? I would like to share one of my experience when operating the UAV. So sometimes when we take off from the ground, we feel that okay, the wind is not strong, so it is very good and happy to start my mission. But when I fly in a very high level, for example, like 800 meters high, the wind is always different from that you feel on the ground. It means that I stand on the ground, I feel very happy because it is not windy at all. But the wind speed over the high level can be very strong. At that time, my UAV could barely move for a meter because even though how I use my sport mode, I use the highest speed of the UAV, the wind is even stronger than the UAV. So that what I do, I could only land my UAV and then go back home. I can't do anything. So always consider about the wind as a factor. So here is my some reminder. So study the weather forecast is really, really important. No matter the local weather, which means that the weather of your mission mission area, the regional weather or big area weather. So we always need to consider the weather source from weather forecast from different source. In Taiwan, we have the CWB, the official weather website. And sometimes I will also consider the weather from other outside websites, so I can have a bigger picture to see what's going on for the weather. And very importantly, you need to know about your UAV limitation. So how fast can my UAV fly? So if my UAV can fly, let's say 20 meters per second, so I need to compare the wind speed to the weather forecast to see that, okay, whether my UAV can operate in such weather condition. So knowing your UAV limitation is very important. Okay, the other one is about the terrain. So it is very, very important as well. So in some mountainous area, it may not be too possible to operate some fully automatic flight because there are a lot of obstruction and it is not safe to do it automatically. So how close is my emission area with those obstacles? And sometimes the control signal may be interrupted by those terrain as well. So we need to consider the terrain very carefully. Okay, so here is a very short brainstorming for you. So after I talk about those considerations, just like the weather, the terrain, and the airspace, and so on. So can anyone just give me some more examples about how your consideration when you do your preparation job? So you can think about it. Okay, so in the session 4, so it is simply the part 2 of the operation procedure. I will talk about how the time window for operation. Of course, we have plenty of time during the day from the sunrise to the sunset, but normally it is not all the time that we can operate in the daytime. There are some restrictions. So what is the time window for the operation? What is your consideration is very important. And some of the concern during and after the operation. Okay, so here is the question. What is the most suitable time for your operation? So as I mentioned, from sunrise to sunset, which means that you have the daytime, you have some from the sunlight. However, for most of the missions, for example, the aerial photography, we won't consider too early or too late of the day because it will create a shadow. The shadow, when the angle of the sun is too shadow, also it will create a large area of shadow on the ground. So it may not be very suitable to use. So for too early time or too late of the day, normally we won't consider it. Okay, so for some season, wind may pick up after the afternoon. So maybe around 12 to 1 p.m. So starting from that, the wind will pick up and it will become very windy until almost the end of the day. So is the windy hour suitable for your operation or suitable for your UAV? Okay, so for some area, military operation and may be carried out or some air patrol or by the sky police or so on. So some area they do have the air traffic control restriction. So during that period of time, you may be restricted from the operation. You cannot fly your UAV. So you also need to erase that time. So throughout the day, hey, your time to operate the UAV may be a very, very, very limited, just like the green area here. So what does it mean? It means that the time is so restricted, and that's why you need to do your preparation more carefully to maximize your efficiency. Okay, so during the operation, when you have done all your preparation, you prepared everything for the weather, from weather is okay, airspace is good, and all your flight plan, all your calculation and everything is just done. So are you just okay to lay down and sit back, have a cup of coffee, and then close your eyes to enjoy your wind and music? It is not the case. So during the mission, it is very important to monitor everything, including your environment. Okay, what are these? I can give you an example is the high-flying birds. In Taiwan, in particularly, the eagle is one of the threat for our UAV operation. Some kind of birds, they may be very curious about how our UAV, because it can fly just like them. They can fly very fast, very high, so they maybe just want to take a look of it and getting very close. Those curious birds are okay. But for some birds, they may be very aggressive, just like eagle. I think some very interesting movie, maybe you can find it in the internet, is that some eagle, they attack the UAV. So they just simply grab it and then may think that it is their prey. So in my past experience, I had operated in an reservoir area. So when I look up to the skies, I found that, oh, there were just uncountable amount of eagles. So it was pretty scary. So what I did was that I need to take off quickly and then climb above those areas as soon as possible in order to avoid those birds. Okay, another thing here which I think is a big hazard are those invisible power lines. It may look very visible for you in the PowerPoint. However, when you are on site in the area, those power cables may be invisible for you, because when you are looking those cable in the direction of the sun, which means that they are all backlit, it is always very difficult to see those power cables. It is a really real threat for those takeoff and landing aircraft. So you need to pay attention and very be careful of those. Okay, the other one is the sudden weather change. Even though you have studied your weather forecast carefully, but weather forecast is just a forecast and it has some error. Sometimes, particularly in the summertime, when the weather is much unstable, the weather forecast may not be as accurate as what we think. So in case the weather change and not according to our plan, you need to think about, should I terminate my mission, or what is my alternative? Okay, and the other one is, of course, about your surrounding. You are at a open area. There are so many different things happening. Some people may fly their remote control airplane around, so you really need to pay attention and also need to communicate. In case some people, they are flying around, you need to talk with them and to cooperate with those persons, and to see when you need to land your aircraft, just ask them maybe to land first and then you can land afterwards. So communication is very important. Okay, so here is another of my advice, is that to check your UAV after every flight. Check it every flight doesn't mean that check your UAV after the accident or after you had a crash landing, because there are so many things happen in flight. So check it every time to ensure your UAV can function normally. Because during the flight, it has the propeller rotating all the time. And it may hit some insects or even some big animals in flight, and you don't know. And you can see for the propeller here, some damage at the edge of the propeller. So those edge or some incomplete propeller, so it will reduce the efficiency of the flight, or even to have some hazard, or maybe the propeller just fell off during the flight, so how your UAV will just simply crash. So it is always important to check your propellers. Okay, another very important items you need to check is your battery, just like your cell phone. And obviously, the picture on the left-hand side is a cell phone battery. You can see it's swell a little bit. Why? What is the reason of the swelling of the battery? Is that when the battery is getting old, it charge and recharge, and the cycle completes for lots of times. So it will release the heat and some gas inside. It will make the package become bigger and swelling. And of course, if the battery itself it is a poor quality or poor design, the effect may be more significant. Some mechanical damage, maybe it dropped from the ground, or some heating from other objects, so the battery will swell as well. And sometimes deep discharge of the cell or excessive temperature. So therefore, never place our lithium battery in the under very hot temperature or inside your car during the summertime. It is very dangerous. Okay, as there are so many things that we need to check before the flight or after the flight, so it is always a very good habit to create your own checklist. Nowadays, when we buy a UAV, normally we don't have a checklist because the manufacturer just simply don't create one. But you can take a look of the reference from the internet. There are lots of checklists to tell you what should you check your UAV, what kind of items you should go through before you take off and after you land your UAV. It is always a good habit to do it because yeah, it can make sure the safety of your next flight. Even though you are very familiar with your UAV, for example, I've flown my UAV for the last few years. I can fly even I close my eyes, but you also need to check it carefully for every time you take off and after landing. And the last statement is very important, is that treat the safety as the first priority. Not only the safety of the UAV itself, but also the personnel around you, and of course your life is very important. So the safety of the personnel is the first priority, and after that is the UAV itself. So it is not important if you cannot complete the mission. So if you can't do it this time, just do it next time. But the safety is always the most important priority. So here I'm going to talk about how the oral photo and also the processing. So oral photo, I will do some introduction. So what are these? And the principle of the oral photo and how to proceed it and how to make my own and some applications. So oral photo may be a new terms for some of you, and in simple, just like a Google Map, I believe that all of you have the experience of using Google Map just like on your cell phone. So in theory, this is an image, a geometrically corrected aerial image. It means that it is uniform. The image is uniform from one edge to the other one. So it will correct for all the terrain effect, all the lens distortion. And the measurement is the same for the entire image, which means that for every corner, every area is uniform. Okay, so what is the principle behind? Here is an UAV. So it flies for a fixed, unchanged altitude and also the speed. So it takes a picture one after the other one, and the other one, and the other one. So it will give you the same scale. So the scale of the picture for the picture 1 and picture 2 and picture 3 are all the same, and also a overlapping rate. Overlapping rate is that for the picture, the first picture and the second picture, it will overlap a little bit in order to combine the picture all together. So when the UAV fly at the constant speed, so the overlapping rate will be the same. So in order to make a good oral photo, so the overlapping rate should be at around 70%. And it will be combined by the common ground features. Okay, so as you can see here, so the drum fly across in this way. So for the first picture, the second picture, and the third picture, they have the same scale, and the computer can combine it one after the other one. So I think it is very easy to understand that. So more image can create a larger, can cover a larger area. So you can see this is the first picture that's covered by the UAV, and the second one. The first one and the second one, and they have some area, some common area, and same as the third one. So that's why they have some ground feature that can be recognized by the computer, and they can be combined one after the other one and the other one, and eventually you can have a big picture covering the area that you want to see. Okay, so lower the altitude here gives the higher ground resolution. So what does it mean? Because for every camera, they have some specific resolution. For example, I have a 4K camera. They can have a certain details. So you can imagine when you fly lower on the ground, so you can have a more detailed and more decent picture, and giving more details. For the normal UAV operation, and we create a map, it can go up to around 10 centimeters per pixel. It means that when you zoom in the picture, for 1 pixel, it represents 10 centimeters. This is a pretty good resolution. And if we use a better camera, or if we fly lower, getting close to our target, so you can have an even and better picture and higher resolution. So here I say higher resolution camera can give a better result, of course. So if you can carry a much bigger camera and better resolution, so a decent map can be created. So how can we create my own oral photo? In the past, the aerial survey is a very labor-intensive, a very tiring job. You can see this was one of my projects in the past many years ago. So we need to fly our UAV manually, not automatically. So we need to take a picture one after the other one manually, and the other one. So after we collect all those pictures, we need to use the ground features to match another one. The first one matching with the second one, and the third one matching with the previous 2 pictures, one after the other one. Sometimes we cannot fly at a very constant altitude. It may be sometimes higher, so we need to adjust the scale, and sometimes lower, we need to adjust the scale as well. In order to take the area that we are interested to look for, sometimes it will take us a day or 2 to complete this process. It is very time consuming. But on the other hand, it is also the only way that we can do to take the pictures in the disaster time. However, nowadays, it can be very convenient. The picture on the right-hand side, you can see a lot of yellow lines. So these are the routes or the routing, and that's we as a controller to command to a UAV. So you can see a H here, which is representing the home point where we take off. So how we will command the UAV fly for the first checkpoint, and then turn around to fly all the way. And then as the video that I showed previously, the UAV will take pictures automatically according to the command. So all the way when it finish all the routing, it will take a lot of picture in this area, and everything can be just done fully automatically. But it sounds very easy. Just press a button and then it will fly itself. But you need to know just what I said before. Your preparation is most important. For example, is there any terrain, any mountains, or any towers, power cables nearby? So if there's any, so maybe you need to increase your flying height so that you won't crash onto those obstacles. So all those preparation work is very important, and when you finish them, you just input the command and the UAV will complete the job. So all those commands will be stored on the flight computer, just like the brain in the flight computer. So the UAV will fly automatically, and it will also control all the control surfaces and also the camera shutter to take the picture one by the other one. So now the controller is no longer controlling the aircraft throughout the flight. So he is now the monitor to see if any system is working properly. So is everything going well as planned? Okay, so as nowadays, everything can complete almost in a automatic procedure. I say here is around 80% of the auto photo processing. So why it is around 80%? Because the UAV will take a lot of pictures from takeoff to landing. But not all of the pictures can be used, or maybe not every picture is very useful. Particularly during the takeoff and landing phase, we will just erase them. So removing those pictures, and some pictures, maybe the image is blurred or covered by the clouds. So we remove those pictures, and then we will input those pictures into the software. Here are two very useful tools that we normally use. I particularly use the Pix4D, which is a very good software, and some of my colleagues, they use the Photoscan. So, and of course, there are so many more software in the market you can use. You can pick your own one and then to create the aerial mapping. So depends on the performance of your computer. If your computer is powerful enough, so your mission, the mapping can be created in just a few hours or even shorter. So that's why we see those results is almost a real-time outcome. Particularly for the search and rescue or some disaster timing. So it is very important to know the real situation, the large-scale situation, and for real time. And there are some other applications and theories on the 3D modelings, and Professor Yeou will be covered it on another section in the 11th of April. Okay, I'm sorry he said my lecture or my sharing is a little bit shorter than I expected. And thank you very much for everyone for your time in this afternoon and listen to me. And if you have any questions, just feel very free to leave a question and below or in the questionnaire. So maybe I can answer your question one after the other one. So thank you so much for your time. And here's the end of my sharing.
Thanks for Mr. Chou. Mr. Chou, some question in chat room. Can you see?
Oh yes, okay. Let me see. Okay, first of all, I can see a question, and is that the barometer is used to measure pressure? Yes, correct. Barometer is an equipment to measure the air pressure. It is something to give a reference for the brain of the UAV to tell about, okay, this is the air pressure that I measure, and theoretically, what is your height? But for most of the time, you can, it is always a reference only because it is not very accurate, particularly when the cold front come or some warm front come. So the air pressure always change dramatically. So barometer is a equipment to give you the local air pressure and can tell the equipment to tell the UAV what is the height. But this is just a relatively very rough idea of the height to give you the redundancy as a system. Okay, so the other question is that what are the flying restrictions in using real UAV? Okay, so I think it is a very wide open question. And as I had mentioned, the first of the very important restriction is the airspace, as I mentioned previously, because simply you shouldn't fly around the airport. You shouldn't fly around the military base. So you will have big trouble when you are doing so. So some other restriction is maybe about the restriction of your skills, restriction of your UAV, the structure itself. So all of those combining together the firing restriction that you mentioned about using the UAV. Okay. Okay, and at the meantime, and thank you so much for all your encouragement and also very positive feedback. And I believe you may have some more questions. Okay, let me see. Okay, I can see a question is that want to ask about how to create a perfect or decent 3D model for a house or an object. Okay, so as you may find that 3D modeling will be covered later on in the by other lecturers, but here I would have some tips in order to create a perfect or very good 3D modeling. Just same like the aerial mapping. So when you're getting close on the ground and you can get more details and have more decent picture. It is same for the 3D model. So when your UAV is getting close enough for the object or a building or a house, so more picture and closer for more details. Every angle, you take every angle of the buildings, so you will get more details and decent pictures. So you can have a higher chance to create a perfect or very good looking 3D model. So I hope these tips will be useful for you. Okay, another question is that some UAV can identify the lat long coordinates of a particular location in the image it is taken. Oh, okay. Yes. So for those UAV which equipped with the GPS sensor, so it will tell the UAV what is the exact location at this moment. And on the other hand, when the UAV fly across and take the picture, at the picture itself, it will have written in the GPS coordination, the latitude, the longitude of the location where the picture is taken. So when you extract the photo from your UAV and you see the full information, you will see the GPS position of that image. So because the GPS just simply input or simply write the location from the GPS receiver to the image to the camera. Okay, so for the software that I mentioned are those open source software. So I mentioned about how the Pix40 and also the and also the photo scan. Unfortunately, so those are the software that we need to purchase. But as far as I know, how they have some child version that you can try them on. So you can just search those software, and I think they have something like 15 days free trial. So you can try on how to see all those functions. Okay, so for the last question here, okay, do GCPs are necessary during capturing jump image? Yes, I think so. It is very important to increase the accuracy of the pictures. So I think it is very necessary. Okay, so yes, thank you so much for all your questions and positive encouragement here. If you still think of any other questions at this moment, it doesn't matter. Just leave those questions to the questionnaire, and I think I will try my very best to answer your questions later on. Maybe I will keep in touch with you through email. Thank you.
Thank you, Mr. Chu.
Okay, thank you very much.